Renewable Energy Technology Laboratory. Now we are going to see the experiment on simulation study of solar PV energy system. The aim of the experiment is to simulate and analyze the characteristics of PV energy system, that is the voltage, current and power of a PV energy system by using the MATLAB Simulink software. So the apparatus required is the MATLAB software which have a Simulink package. Here, the recent version 2020 has been used. So this is the simulation diagram where the PV array has been taken as a default icon present in the toolbox. And for the PV array, the input is irradiance and temperature. Both the irradiance and temperature is standard value has been given, which is 1000 watt per meter square and 25 degrees Celsius. And the output of the solar panel is DC output, so that a plus minus has been taken and it is given in parallel to the voltage measurement block, which act as a voltmeter, and the current ammeter is connected in series, that is current measurement block is connected in series. And I have taken the output voltage, current and the power product of voltage and current gives the power. So the final output voltage will be like this. So this gives the current and voltage versus current and voltage versus power. So this can be executed in the MATLAB window. So here for entering into the MATLAB window, initially when you enter into the MATLAB window, this page will be open. Here the command window, current folder and the workspace will be available. So here in MATLAB we can do two types of programs. One is by writing the program like C++, we can write the code and we can run. That is by using the script window. Whereas for renewable energy laboratory, we are going to design or model the experiment we need, so that we are using a Simulink library. So here there is a Simulink library. If I click the Simulink library, then we can find n number of components present here. So there will be a communication toolbox, DSP toolbox, embedded fuzzy logic, like that, power systems toolbox, like that. There are n number of toolboxes available in the Simulink library. So based on our need, we can pick the components and we can design it. So for renewable energy, initially I can open a new window by clicking the new model. So once the new model has been opened, I can save it by going into a file. I can save it in the desktop. For example, I'm saving it in a desktop by a name it will be saved. So now you can see the in for a renewable energy, you can have a simscape. In library you have a simscape. In simscape there is a sim power systems. In some sim power system there is a specialized technology. In specialized technology you have renewables. In renewable, now I am going to design a PV array, so I am taking a PV array. So this is added to here. You can see add block to model So if I click that, so yeah, the automatically the block will be added to the new window. So here we have an input terminal. For example, in so PV array, there are many parameters. So if I double click the window component, so the block parameter will open. So the block parameter will have for example, here the number of parallel string, number of series connected modules, and I can have a maximum power, open circuit voltage at maximum power point, temperature coefficient, cells, how many cells per module has to be decided. These can be selected by using the different solar panels. So there are n number of solar panel models which has been preloaded in the kit. So after selecting this, I can give apply and then I can give OK. So once I have given this, then I can go and search the other component in the Simulink library. So whatever component we need, we can search in the search window. And if you give voltage measurement, the voltage measurement block will come. And if you need current measurement or any other constant block, if you search it, so the constant block will come. So like that, you can pick and place all the components in the tool window, and you can give the connection like this. So you can connect each and every component by using a line. So once the connections have been used, done, you can have a run button here. So you can see, if you move the cursor at that, the run button will show. So if you give run, the experiment will run here, and since there is a warning, that is not an issue. There is no error. If there is an error, it will shows there is an error, one error or two error, and where the error is located. like that the error will be shown here. So once the output has been once the experiment has been run, so we can see the output here. So here is an output. So here is an voltage versus current and voltage versus power in the output window. So thus by simulating this experiment, I have analyzed the voltage, current and uh, power of a 1 kilowatt solar PV system.